happened to you in the past that you think might be helpful, stories, whatever it is, please participate in the class. A big part of this is going to be 3 hours. There'll be a couple of videos, but he doesn't want to listen to me talk for 3 hours. I don't want to listen to him talk for 3 hours. So if you guys don't participate, it's just our mouths running. So please participate in this. The first part that we're going to get into with this is a big part of a lot of the things that happen with fire departments, whether it's line of duty deaths or injuries, is complacency. And a lot of times, because of where our call volumes are with things, we were talking yesterday with the group that was here, a handful of years ago, CIcero was doing 300 fires a year. And the one guy said last year you guys did 27. What happens to those fire alarm offs that we go to on a regular basis? We get real complacent. And we stop doing everything the way that we're supposed to do it. We stop preparing the way that we're supposed to do it. And all departments do it. We get a little lazy. And then at 2 o'clock in the morning, when it's the real run, things kind of happen, and that's when things start falling into place where we get injuries and line of duty deaths. And when we go back and look at them, that's where those issues come into place. This first video we're going to show is how NASA did that exact same thing. They acknowledged there were issues. They saw the issues that were happening, and they said, we got away with it, we got away with it, we got away with it. And they built it into the norm, even though they acknowledged it was an issue.
To is I think the identical answer you would come to in the identical circumstance. When your life is on the line, you're going to want a team that's the best holding it in their palm. And how do teams get to be the best? They get there by practicing fundamentals, by doing little things consistently and religiously day in and day out until they become as natural as breathing. You don't even think about it. Now, there's lots of fundamentals out there, but there are 3 that I think have overarching importance to the success and safety of all teams everywhere. And those are the 3 that I want to talk about this morning. When I'm involved with any team, but particularly when there are lethal consequences associated with the team environment, as there are with you in firefighting and emergency response, just as it is in the space program. People die when they don't understand the dangers of a normalization of deviance and protect themselves against that. And I'm going to talk about that. I'll define that here for you in just a moment. I want everybody on the team understanding the essence of responsibility as it applies to the individual as well as it applies to the leadership. And I want a team that's filled with courageous self-leaders. I think Harold really kind of hit on that in his earlier comments. It's self-leadership that determines how safe and successful you can be. It's looking deep inside yourself. It has to be everybody practicing self-leadership for the team to succeed. It can't be 99 out of 100. Every individual, again, particularly in hazardous environments, has to be a courageous self-leader. So I'll talk about that as part of this teamwork program. Now, I'm going to use some experiences I had both as an Air Force flyer and as a NASA astronaut to develop some points on these fundamentals. And sadly, NASA provides me with 2 great tragedies to draw from to make some points. Those tragedies being the Challenger disaster and the Columbia disaster. Now, Columbia occurred 4 years ago. I think everybody's kind of familiar with that disaster. During launch, some foam came off the gas tank, damaged the heat shield. 2 weeks later, Columbia burned up on re-entry, killing 7 astronauts. People are probably familiar with that disaster. Whereas Challenger goes back 21 years ago this past January. Long time in the past. So I imagine most of you are probably foggy in your memories what caused the Challenger to be lost. And because I will be referencing that program, referencing that disaster in this program, I want to take a moment to briefly review for you mechanically what caused the loss of the Space Shuttle Challenger. Challenger was a failure of the right-hand solid rocket booster. These things are so big, they're 150 feet long, 12 feet in diameter, and each of them weighs 1.3 million pounds. They're too big to be made in one piece at the factory in Utah and shipped in one piece down to Florida, where they're launched. So they build them in 4 propellant-filled pieces that are shipped separately by flatbed rail car from the Thiokol plant in Utah down to the vertical assembly building at Cape Kennedy. There, these segments are stacked on top of each other to form twin towers of boosters. The The gas tank is hung between the boosters. The wing vehicle is attached to the gas tank, and then all of this is taken out to the launch pad on this 9 million pound mobile launch platform. Now when these boosters ignite, they burn at 5,000 degrees Fahrenheit and at a pressure of about 1,000 psi. Steel boils at 5,000 degrees. So you have to ensure in your design that the steel of the booster is never touched by the fire that it contains. So there's insulating material to run the inside length of these segments. The obvious weak point in this design is where you bolted these segments together, because there you have a potential leak path for the gas to pass to the outside, melt the steel, and cause a catastrophe. Now, I'm not going to go into the engineering specifics of the joint design that was intended to prevent such gas leakage, other than to say it was based on a redundant flexible O-ring scheme. 2 flexible O-rings. Here's a piece of one of them right here. 12 foot in diameter at each perimeter of those segment joints. 2 of them at each joint were supposed to form a redundant steel-to-steel pressure seal to prevent the fire from leaking out. On Challenger, both O-rings failed on the bottom segment of the right side solid rocket booster. Here's Challenger coming off the launch pad. In that yellow area, you'll see a black smoke being ejected. That's the vaporized O-rings being shoved out that bottom joint. You now have 5,000 degrees eating into that outer wall. As the rocket flies higher, the gas is vaporizing a bigger and bigger hole in the side of the booster rocket. 73 seconds into flight, the rocket comes apart, killing the 7 astronauts. Now what you're seeing here appears to be an explosion, but was not. This was a catastrophic structural breakup. The fire weakened the attachment to the bottom of the gas tank. That bottom just basically fell off. The top of the booster rotated into the top of the gas tank, rupturing that, and under the aerodynamic and G-loads of the moment, the vehicle just shredded itself. Nothing detonated, nothing blew up. That will become important to remember downstream when we talk about crew survivability associated with this tragedy. Now you're going to need that background to understand some of my downstream comments, and certainly you're going to need it to understand my comments about normalization of deviance. What is this? Well, it's that natural human tendency, particularly in pressure circumstances, to want to take shortcuts, to accept a lower standard of performance. Maybe it's a lower standard of personal performance, a lower standard of performance for some team you lead, lower standard of performance for some machine firefighting equipment that you oversee. But it's very human to find yourself in pressure circumstances, and God knows you folks find it on every call. Very human to find yourself in a pressure circumstance and rationalize, I can't execute to meet these standards I've been trained to meet. I'm going to have to take a shortcut. Maybe the shortcut is what Harold was talking about, not doing a proper risk assessment. Maybe it's not having the right communication in place. Maybe it's not wearing the right protective equipment. Whatever. But it's very human in pressure to rationalize, I can't do this job and meet the standards. I'm going to have to take a shortcut. And so you take that shortcut. And guess what the consequences are? There are no bad consequences. You aren't injured. Nobody's injured. The emergency response proceeds successfully. There are no bad consequences to your actions in taking that shortcut. What's that going to do? It's going to loop it back into your brain and reinforce the rightness of that earlier decision to take the shortcut in the first place. So what's liable to happen the very next time you find yourself in these same pressure circumstances? And I guarantee there's going to be a next time, particularly in your businesses. Because there were no bad consequences the last time you took the shortcut, you're going to be mightily tempted to do it again. You do it enough times, and what happens? The shortcut becomes the norm. Here are the standards that you're expected to be meeting. Here's where you are in execution. This deviance is invisible to you. You don't even think about it. It has become normalized into your actions, into your team actions. And what happens with normalization of deviance, it leads to predictable surprises. And if you ever want, and I'll tell you, in hazardous environments, predictable surprises on the job can be injurious and they can be deadly. If you ever want an object lesson in what normalization of deviance can do, a predictable surprise, look at Challenger. Challenger was no accident. Challenger was a predictable surprise. At the time that rocket came apart, scattered throughout navigator contractors and filing cabinets and desk drawers were written documents, memos, predicting that the exact thing that did happen, i.e. failure of this O-ring, was going to happen. And where did people get the information to make such predictions? From the best source available, flight data. It doesn't get any better than to get the piece back and see how it performed. And that's the case with these solid rocket boosters. They're not throwaway items. 25 miles up, they burn out, they're jettisoned, they have gigantic parachutes that are deployed. These things are lowered into the water. Air is trapped inside them when they hit, so they float. Tugboats are positioned out there to put a line on them, tow them back to shore. There they're cleaned up, taken apart, inspected, and used over again. The operative word in this process is inspected. And on 14 of 24 flights before Challenger, Challenger was number 25. On 14 of 24 flights before Challenger, in the inspection process, quality assurance and safety people noted that the O-rings, which were never designed to be touched by fire, were being touched by fire. And they understood the ramifications of their findings. This design is flawed. It's going to fail. People are going to die. And they basically put words to that effect in these various memos. I want to share with you excerpts of 2 of these memos, both of which were written by CIcero engineers, the contractor, to their customer, NASA. The first memo was dated February of '84. This is 2 years before Challenger. And in part, the memo reads, "The recent experience of 2 burned O-rings on STS-11, that's the 11th shuttle mission, raises concerns with STS-13. You know, when I read this, I wonder how come nobody was concerned about STS-12, my first mission. But apparently they weren't. The O-ring leak check procedure is also an urgent concern. Your support in this urgent matter is requested. 2 years before Challenger, the label urgent has been hung on this O-ring design. It's not working." Here's a sentence out of a CIcero memo dated July of '85. This is 6 months before Challenger. The memo was written by Mr. Roger Bougielet, a CIcero rocket engineer. In his memo, he wrote a very prophetic sentence. Here it is. "It is my honest and very real fear that if we do not take immediate action to dedicate a team to solve the problem with the field joint," and that's the O-ring, "having the #1 priority, then we stand in jeopardy of losing a flight, a crew, and all the launch pad facilities." Mr. Bougielet's prediction was only off 73 seconds. He thought the rocket was going to blow up on the launch pad, destroy the vehicle, kill the crew, and take out the launch pad facilities. He missed it by 73 seconds. Challenger was no accident. Challenger was a predictable surprise. Now, I know what everybody's thinking right now. Why didn't the team react to these warnings, ground the fleet, and fix the problem? And the answer is, to a significant degree, the team was laboring under a long-term normalization of deviance. And let me explain. Approximately a decade before Challenger, a standard of performance was established for these O-rings in our failure modes and effects analysis document. They were given a criticality 1 label, meaning if they ever fail, it's loss of the vehicle and death to the crew. So a standard of performance was established for these O-rings. They can never show any hint of a failure mode. If they fail, it's death. And de facto, you have now established a standard of performance on how the team should react if they ever see a problem with the O-rings. Criticality 1 deviance, only one thing you can do, ground the fleet. But that standard of performance was established, as I said, about a decade before Challenger in a no-pressure situation. Emphasis on those words. When the first O-ring damage is seen, it's not...
So when we look at a lot of the things we do in the fire service, and I think when we look at Highrise, we look at anything over 4 stories that we have to deal with. You guys have a 10-story nursing home in town here. I think when we look at any of those type of incidents, any of those type of situations, it's not our norm. What's our bread and butter as firemen? It's our residential structures, right? It's our 1.5-story, 2.5-story homes. That's what we're used to. That's what we train on a regular basis. When it comes to high-rise, look at what Chicago's done. Look at the amount of high-rises that they've done. And every time we get a high-rise fire, what do we do with our SOP for high-rise fires? We change it because we find something that we just learned from the incident that we had that we didn't do correctly. You can look at every one of ours. And we do lots of training on high-rise fires. The amount of high-rise training that you guys are able to do on a regular basis is probably, like most other departments, is probably really low. You probably don't have the time to spend on doing it as well as you want to. There's probably numerous things that you're just not sure how they're going to play out to win till it happens. Then you've got all the other factors that come into play with it. How long is it going to take you to get your assist companies in there? Because let's be honest, how many people are we looking at to truly do a high-rise fire? You get a fire on the 9th story of that nursing home. How many people, how many companies do you think you're going to need up there to truly respond to it the way you need to? Yeah, and I mean, on a bare minimum, you're looking at 30. On a bare minimum, you're looking at 30. Realistically, if you got a long, extended period of time, they're saying you need up to 90 people. What would it take, and how long would it take you to get 90 people to that scene?
Could you get 90? Would you ever have 90? I mean, you probably could eventually, right? What's that time frame for that? Hour.
So a lot of the challenges that we're going to face with this have to do with the coordination that happens at that fire scene. One of the things that plays into that is those radios that are sitting on the desk. How often do we have failure of the radios in those type of buildings? It's a regular thing where communication isn't happening. There are numerous NIOSH reports and incidents that have happened where people know things are going wrong, people understand things are going wrong, and they don't communicate that information for lots of reasons. For embarrassment on mistakes that they made on their part, and they just don't know the correct answers to say on the radio. So these are all things that we have to think about before the incident happens. Let's talk about the life safety risks. Now, we know the life safety risks that we have due to the firemen, but that 9-story nursing home, how realistic, if you have a fire on the 9th floor, is it to say we're going to evacuate 3 stories of that building? How realistic is that going to happen for you guys? What type of manpower would you need to empty 3 floors of that building? How difficult is it for residential structures now to get anyone to stay in place? What does everyone want to do as soon as they know there's a fire in their building? They want out of Dodge, right? They want to get out of there because they've seen all the bad incidents that have happened on the TV. So those are all issues we have to think about. And just the training end of it alone. A lot of times it's difficult to get into these buildings and actually lay line and talk about how we're going to do it and work with those lines inside that building and see if we're going to have enough hose. We were talking about for CIcero here, you guys use 150 feet, 1 3/4 with a combination nozzle. How well have correct? That's what you guys are using? How well does that work for your incidents? How well does a combination nozzle work with the amount of pressures that are going through the buildings you have and the soot and everything that's going to get jammed up in those combination nozzles?
Yeah, we got smooth boards.
You have smooth boards on your
Smooth boards? All right, I think it was Oak
100
Park.
feet.
I'm
Oak
sorry,
Park
I think it was
does.
Oak Park had the combination
Yeah,
nozzle.
start screwing that up.
They're not as orderly advanced as you guys are. So 100 feet of 1 3/4
Yeah.
with a smooth bore.
Yeah.
Okay. What's the tip on the smooth bore? 7/8, 15
15
16.
16s.
Okay. Can we still get something that clogs that pipe?
Sure.
Definitely less likely than an automatic clog or an adjustable clog, without a doubt. It's a better pipe to have.
One of the big breakdowns that happens with a lot of incidents and a lot of fires, especially with high rises, is terminology. I know this area just went to the whole blue card thing. And whether it's blue card or whether it's this or whether it's that, the biggest issue that a lot of places have is when you get multiple departments working together and we're calling the exact same thing 2 or 3 different things. And by going to a system, and it doesn't matter what system it is, if we're all talking the same language, things seem to flow a little bit better and things seem to work out a little bit better because we're all talking in the same way. Time factors are reflex time. What is the difference between a 2.5-story frame sitting on one of the CIcero blocks or that 9 or 10-story building that we have in town? What is the difference in our reflex time, us getting actually water on the fire? For a fire on the 9th floor of that, realistically, how long is it going to take us to actually get water on the fire?
From time of call, alarm comes in, get in the rig, get there, get up to the 9th floor, or 8th floor below, wherever you do.
And 15 to 20 minutes is a pretty realistic time frame, and that's when you look at the statistics of communities that have had them, that's a realistic time frame on how long it's going to take. For a 2.5-story frame, what does it take us? 5 minutes? And that's stretching it, that 5 minutes? So we have to put that time factor into what we're doing. The other big part of that is to get everything in place. What are we going to need? A lot more manpower. We got to call for that help early. We got to get those extra companies coming in earlier. Locating the fire. How big of an issue is that on a regular basis? When we show up and we look at that panel that's sitting in the lobby, what could it be saying? It could be saying we have smoke on what, 3 or 4 different floors? We may have fire alarms going off on different floors. Why is that? How does the smoke travel through these buildings? We've got a nice chimney usually right in the middle, right? We've got that elevator shaft that's going to send smoke to different areas of the building. When we walk into some of these residential structures and you walk into the lobby, what's that smell you get right away and you know what it is?
Urine. That's the nursing home they're at, yes. How about with that burnt food? Right? Cooking smell? Maybe an electrical smell from a motor of an elevator itself or something. Those are your more common ones, right? It's distinct smell. It's electric or meat on the stove, as we call it, but it's just some common terminology, but you know what it is.
And you could have it on the 6th floor of that building and smell it in the lobby. And look how fast that travels. Look how easy that smoke and that smell is traveling throughout that building.
What else did it travel up? People leave their units. What do they do? Leave their doors open up doorways, open up stairway doors, and only another possible place would be your plumbing chases, right? If they ain't fireproof or fire stopped.
We have to think about getting that equipment in place too. If you lose the elevators early in it, and you've got to get that equipment up to the 9th floor of that structure, what percentage of your crew may be done at that point just because they had to carry all that equipment up there?
Who's your fittest guy? Who's the fittest guys? Yeah, you definitely. Yes, I'm with you. Even the fittest guy here, couple lengths of hose on your shoulder, air pack on, fully equipped, all your bunker gear. What do you put on you with bunker gear and air pack as far as body weight? Average.
Our air packs, 100 pounds.
They say about 50. They say you had about 50 pounds. You're in really fit shape, so you had extra weight. But they say about 50 pounds. That's not adding the hose. So add 50 more pounds to you, limited flexibility movement up to the 8th, 9th floor. Most people are spent. Now we still have to start operation.
When we were putting this together, the guy was teaching me yesterday, he's got friends who are out in LA and Denver, and for them, they never are allowed to use the elevators. They have to, if it's 40 floors, they got to climb 40 floors. Now they do things in their SOPs that are a little bit different. They can change into gym shoes while they're bringing the stuff up and everything like that, which is going to lessen the fatigue, because we all know walking in these boots up 10, 15 stories is going to be more fatigue than if we were using our gym shoes. But they don't touch elevators at all. They don't use them at all because they don't want guys getting caught in them. They've had a couple incidents that have happened where the guys have gotten caught in the elevators. So if it's 40 floors, then they hike everything up to 40 floors. What use is any of those members other than to be mules at that point? They're of no use to anything else which is going on there. We talked a little bit about this already, getting everyone in place, getting that automatic companies coming in a little bit earlier, and we need to make sure that we're calling them early and we're calling them often. Let's talk about access to the building. And a lot of the buildings that we go to, whether they're residential or commercial or senior living buildings, the big thing that we have is access problems. How many times have we shown up just for something like a pot of meat or an ambulance assist and we can't even get into the buildings due to the fact of the security that's set up for the building already? We have forcible entry issues with different types of doors and different types of locks in different areas of that building we may not have access to. Setbacks. How does that come into play, the setbacks with our truck companies? You're gonna have situations where if your aerial is 150 feet away from the building, of what use is that aerial even to a 3rd or 4th floor window? Are you going to be able to use the aerial to it? Absolutely not. So those things you have to think. Landscaping, you could push the rigs back, and even carrying the gear to that building, it could set you back another 150, 200 feet from the building, so you're already walking 200 feet before you get to that building. Parking garages, again, they could be set up on the sides of the buildings where you are pushed back so you can't use your aerial devices. And then we have service areas which cause problems where they have usually better locks in those areas of the building, right? Because they don't want people going in through back doors or rear doors or breaking in that way. So usually service areas are tightened up a little bit more.
Does it change what tools you bring in for this access? As Jeff's talking about forcible entry, service areas, harder again. Your complement tools change what you bring? Yes. You switch to a hydroram, rabbit tool, irons as compared to residential?
Again, when we talk about the locations of the fire, human error, for most times when we get called for fires in residential structures in any type of high-rise incident, where are the calls usually coming in from? If we have a fire on, say, the 9th floor, where do the calls usually come in from?
Which ones, though? What usually happens with smoke? So where else do those people call first usually? If not that fire floor itself, what? A higher floor?
So those are things we have to think about as we're approaching that building. Is we may be getting calls from the 15th or 16th floor, but it may be on the 9th or 10th. So we have to approach that building a little bit differently than we would our 2.5-story frame. Sometimes we also get calls from our passerbys, right? People are driving by, they see a smoke or they see fire coming out of a window. You got a 35, 40-story building. How close are they going to be with what floor that is actually going to be on? They could be within 5, they could be off by another 10.
Physical evidence, is that a hard one for high-rise buildings? Unless the window's blown, unless it's something already loose, that's definitely a harder thing to have in a high-rise fire compared to residential. Usually you see it sooner in your residential fires. Where high-rise, large area for spread of travel, smoke, and fire, harder to identify that physical evidence.
Let's talk about windows and high-rise fires. What are some of the issues that we run into with the windows for high-rises? They don't open, and if they do open, what do? A crack at the bottom, the ones that do? Is it easy for us to ventilate those windows? What are the dangers in us ventilating a high-rise window? You got falling glass that could go long distances depending on the wind and depending on the height of the structures. Sometimes with the elevators for these buildings, there'll be different zones. You may have a low-rise, mid-rise, or a high-rise. You could have to transfer from an elevator to different floors. You may have elevators that only go up to the 25th floor. At the 25th floor, you've got to cross over to another elevator to get to the rest of the building. You got to know for the buildings that are in your still districts, do you have a mechanical room or do you have a hydraulic pit? How is that elevator operated? What is the mechanisms that make that elevator work? Because you may have to override something. For most of the buildings that we're going to go into, we should have some type of ability to gain access to these elevators. For those buildings, there should be a box very near those elevators that carries the keys for those elevators so we can put them into phase 1 and phase 2 so we can gain control of these elevators. Some people carry the keys on their gear themselves, some have them in the rigs depending on how your department is set up. But that gives you access so you can put those elevators into the phase 1. The first thing you want to do is locate the box. It's usually in a very easy site area for those elevators, and for that certain bank of elevators, it'll have the keys in it. Now, depending on how many elevators you have will depend on how many keys you have in that box. The way it's supposed to be set up is if you have 3 elevators, there should be 4 keys in the box. 1 key for each elevator, 1 key to put it into phase 1 in the lobby control area. When you put the key in, the key to put it into phase 1 should turn to the right. That should put it into the on position. For most of the new elevators, that key should lock into place. There are some of the older elevator systems that you're still able to take that key out and use that key. Hopefully, when you put it in phase 1, that key stays into that spot. You may have also the situation where you have different banks of elevators in the building. You may have to recall different sets from different areas in the building. The thing to remember with that is we want to recall them if they haven't recalled themselves right away. And what's the reason for that? Right, we don't want civilians using the elevators while we're trying to figure out what's going on or if we do have a fire happening in that building.
Some newer buildings and newer systems, they might have an automatic phase 1, the alarm goes off. It may automatically send those elevators down to the lobby, and they should. If not, then you have to do what Jeff's talking about, actually physically put the elevator into phase 1 mode.
When we bring the elevators into the phase 1, what will happen to those elevators that are on the different floors or while they're operating in that building is, if it is stopped on a floor with the doors open, a beep will sound, those doors will close. Once it is safe to close, that elevator will return to the ground floor without stopping at any of the buttons that have been pushed in that elevator. If that elevator is going up or down, while that phase 1 is put into place, it will stop at the next floor. it will then return to the lobby without those doors opening. All of the controls in all of the hallways will become inactive, and any of the controls inside the elevator will become inactive, so they cannot stop the elevator.
Have you guys ever messed with phase 1 or had a chance to at all? Anyone here? Familiar with it a little bit?
Yes.
Okay. Anyone not? Okay.
Once the elevators reach the lobby, those doors will stay open. And what that does is it gives access for each of the people who are on the civilians to come off the elevators, or it lets us know there's no one in them. Now we have control of those elevators. The next step for us would be the phase 2 process. And that would be a firefighter grabbing another key, going into the elevator itself, and turning on to the phase 2. What the phase 2 allows us to do is have control of that elevator. So if we're going to take a group of guys up to whatever floor, and we decide we're going to use that elevator, we put it into phase 2. Our next step is we have to close the doors. Because it's at the lobby, the only way to get the doors to close is to hold the door close button until the doors completely close. Then we can select the floor that we would like to go to. As we're going up, if we're going up to, say, the 25th floor, what's a smart thing we should do before we leave that elevator, and we should do every so often? We should stop that elevator, we should open those doors and take a light, and we should look up and see what's going on in the elevator shaft above us. What are we looking for?
Smoke.
Smoke. What else?
What could be in high rises to indicate that there's a fire that would give us a sign through the elevator shaft? What could be
Water.
coming down? Water.
How much water does it take to shut down an elevator?
A teaspoon.
You're close.
You're close.
A large cup of coffee. If a large cup of coffee comes down that elevator shaft and hits the elevator in the right spot, a large cup of coffee could shut down that elevator. Now you could have two situations. You could be trapped, or you could be where you're stuck between floors on that elevator, and now you're a rescue instead of a rescuer. So it's important to stop every 5th floor. What's another reason why we're stopping every 5th floor or so? To make sure we have control of that elevator. There are numerous incidents in high-rise fires where the elevators have lost control due to the incident that's going on. We want to make sure that we have control of that elevator. If for some reason we're traveling up that elevator and we do lose control, what are some options that we have that we can gain control of that elevator back? One, exactly. If we take that key out, what does that elevator automatically do if we take that key out? It goes back into phase 1. What happens when an elevator goes back into phase 1? It stops and comes back down to the lobby and opens the door. That's a great option. Another option is there's a call cancel button in that elevator. If you hit the call cancel button, it should turn off any of the lights that you have hit. So if I hit 5, 10, 15, 20 on that elevator, we stopped at 5, we tried to stop at 5, it didn't stop. If I hit that call cancel button, it should cancel all those lights and take us back down to the lobby. Another option is we can call downstairs. We can have them turn off their phase 1. What will that do to all the elevators again? It'll bring them back down to the lobby, because once you turn phase 1 off, the elevators have to reset. And the way they reset is they come back down to the lobby and they open the doors. Worst case scenario, if we cannot get these elevators to stop, we can take a Halligan bar and we can pry those doors open. What happens to that elevator as we start to pry those doors open?
We'll stop.
Right, those locks kick into place once those doors start to open, and it locks the elevator into place. What is the negative to this now?
Between floors.
Right, now you're stuck. Someone's going to have to get you out, but you're at least not going to the fire floor. So that's the option you have to look at. Is it's better than actually going to the fire floor and getting stuck on the fire floor, or having those doors open on the fire floor itself.
So that's how important that travel up, to make sure you have control and you're constant checking. Smoke, water, conditions, are they changed on the lower levels as you're going up? Get your layout of the floors as you're going up, make sure you keep your bearings, and up you go.
Some newer alarm panels will have the ability to put it into phase 1 from the alarm panel itself. Or it'll give you some type of signal or some type of acknowledgement from the alarm panel that it is put into the phase 1. So if that happens, it just needs to be notified on the radio that that has already happened. inside the elevator there will be a light, and if that light for the fire department signaling system is lit, that will acknowledge that there's something going on with the shaft itself. With the new fire codes, all the hoistways or shafts for the elevators are supposed to have some type of system in there. They should have a smoke detector and they should have a sprinkler head on the inside there. If you have a smoke detector going off in that shaft, or you have a sprinkler head going off in that shaft, that little light in the elevator should acknowledge that that's going on. Is that an elevator that we want to use? Probably not. Will that elevator still work? Absolutely, but it's probably not something that we want to put our members in. In 1981, the Chicago Fire Department had an incident at the Willoughby Towers where they responded to a possible structure fire. The firemen took the elevator up to the 24th floor. They got off the elevators, they went up the staircase to the 25th floor, and they tried to open the door. The door would not open. So they thought, we've got to get to this 25th floor. Let's go back to the elevator on the 24th floor, let's take it up to the 25th floor. When they did that, the doors opened on the 25th floor. They got out, they experienced heavy heat, heavy smoke. They made it back to the stairwell area, they regrouped, they realized they were missing one of their members. As they went back to look for the member that they were missing, they had a second member do the exact same thing the first member did. What happened was, when their elevator door opened, the one member crawled directly across, the elevator doors were open. He fell directly down that elevator shaft. One of the guys who went back to look for him did the exact same thing, fell down the shaft, and a third guy caught himself. He fell halfway down, caught himself, and was able to pull himself back up. What they realized after the incident was they were doing work on that floor. The maintenance people, they had the elevator doors locked open, they had the elevator there, they were loading it with crap. While they were loading it with crap, the stuff started on fire. Due to the fire, what happened to the elevator was slowly it lowered, and it lowered about 16 stories. But those doors still stayed open because they were locked open. That's the shaft that the guys fell down. So it's just something to think about when you're getting off the elevators. They weren't grouped. They really didn't have a good plan on when they were coming off the elevators. We ended up losing 2 guys and almost lost a third. Do any of you guys remember the story of the Memphis fire and the guys that got killed at the Memphis fire, Memphis, Tennessee? We're going to watch a video on that. We're going to talk about the things that happened and all these incidents that we're talking about and the things that happened. The big thing we have to remember is, are these bad guys? Absolutely not. They're not bad guys. But they're just mistakes that happen, which we all do on a regular basis. And sometimes enough of them line up where bad things happen. And this Memphis fire is definitely one of them.
As Jeff pointed out, this Memphis fire ties in really good. That first video you saw this morning about the discrepancies or complacency. That's what happened there. 750 Adams with William E. Bridges is one of the guys. It's Regis Towers. A bunch of things happened. It was normal for them to respond to this building a certain way. It was a high-rise building with a lot of alarms, a lot of calls, a nuisance building. I don't know if you're building O2, you had a lot of automatic alarms had or calls to because the people in. That's what this building was. After multiple runs on the same day they went there, how complacent do you think they were at 2 in the morning? A lot. And a lot of things went wrong from there.
But rather that so others can learn from these experiences and can survive in the future. Here now is the story of the Memphis fatal incident in the words of the Memphis Fire Department.
All right, at 2:03 a.m. on the morning of April 11th, 1994, the Memphis Fire Communications Bureau received a call from Miller Protective Services advising that they were receiving a trouble alarm for 750 Adams, located here in Memphis, Tennessee. This particular building, since October the 15th of 93 through April the 11th of 94, the Memphis Fire Department had received 29 different type calls there. Some of these calls are just normal false alarms, food left on the stove burning while the residents leave. There are some harassment calls. We have had cigarettes put out into the smoke detectors in the hallways. It's just that type of activity that goes on in this particular building.
Yes, this is Miller Domestic calling. We have a fire alarm at Regis Towers. We have no transmitter number. The address is 750 Adams.
Okay, do you have a floor? Where's the alarm going off?
No, just has been on fire.
Okay, then.
Thank you.
Bye-bye.
At 0200 23 hours, 3 engine companies, Engine 7, 1, and 5, 2 trucks, Snorkel 13 and Snorkel 2, and Battalion Commander 1 were dispatched to the scene.
Automatic alarm for the Regis Towers, 750 Adams Avenue in North Manassas Street. The access code is 7586. Engine 715, Snorkel 13, Snorkel 2, Battalion 1 respond. Miller automatic alarm for the Regis Towers, 750 Adams Avenue in North Manassas Street. Access code 7586. Engine 715, Snorkel 13, Snorkel 2, Battalion 1 respond. 7.
Each company assigned to 750 Adams had a minimum manning of 4, which included an officer, a driver, and 2 privates. Both snorkels had a basket on the front and were capable of water tower or rescue operations. At 0200 08 a.m., Engine 7 arrived at the front of the building, located on the south side, and radioed no evidence of fire.
Check Engine 7 Adams, command 208.
750 Adams is an 11-story non-sprinkled concrete and steel apartment building. There are 2 elevators that travel from the 1st to the 11th floor. Both elevators are equipped with a safety shoe to prevent the doors from closing if they hit an obstruction. Neither elevator has an electronic beam to prevent it from closing if the beam is obstructed by smoke. The corridors run east to west and are 5 feet wide and 100 feet long with an open elevator lobby in the center. The fire alarm system monitors 18 zones for fire and trouble conditions. The annunciator panel is located in the 1st floor lobby. There are stairwells located at the east and west end of the corridors which exit to the outside. They are 7 feet wide and have 1 intermediate landing between floors. The doors to the stairwells are metal and have self-closing devices on them. The stairwells provide a safe egress for the tenants and a safe access for firefighters. Each floor contains 13 living units. The tenant doors are 1 3/4 inch solid wood with non-rated metal frames with no automatic closing devices. The doors, which were closed during the fire, did not fail.
Engine Company 7 at the front, or the Sector A, south side of the building, entered the building through a set of double doors. Prior to entering the building, the officer, 1 private, exited the pumper, put on their SCBA, and entered the front door of the building. The other private, with the assistance of the driver, donned his self-contained breathing apparatus, took 2 hotel packs, which are 2 sets of 1 3/4 inch hose, 150 feet long, coupled and belted together, over his shoulder, and entered the building. At the same time, Snorkel 13 arrived at the rear of the building. They met the officer and 2 privates off of Engine Company 7 and one of the 700. And the officer on the Engine Company 7 advised the officer on Snorkel 13 that they had a trouble light showing on the 9th floor.
On the 9th floor, let's go back and see what it is, guys. All right,
All 5 personnel got inside the elevator. It was a pretty tight squeeze because they were all wearing that CBA with bottles on, and one set of hotel packs. The officer on Engine Company 7 did push the elevator button to the 9th floor, which was indicated on the annunciator panel.
There had been no indication that this call was any different from all the other nuisance calls. But this call was different. An arsonist had set a fire to the southeastern apartment on the 9th floor. Hot gases and smoke filled the entire 9th floor hallway, wall to wall, ceiling to floorway, and were beginning to vent on the southwest side.
The firefighters inside the elevator had their SCBA on, but did not have the face pieces in place, nor did they have their cylinders activated, nor did the firemen have their pass devices activated. All firemen on the scene had full turnout gear with the portable radios. As the firefighters were riding the elevator to the 9th floor, they received a radio message from the driver of Engine Company 7, who advised that he could see smoke coming out of the west end of the building on the 9th floor. Just as the Engine Company 7, who was in the elevator, acknowledged by radio, check Engine 7. The elevator doors opened on the 9th floor. All 5 firemen encountered moderate to heavy heat, very dense, very thick, zero visibility smoke. Being caught somewhat surprised and unprepared for what they had envisioned, because they started scrambling to get their face pieces on. 4 of the firemen exited the elevator. The one fireman who was carrying both of the hotel packs was in the elevator trying to don his face piece and at the same time hold his foot on the elevator door to hold the doorway open. As he attempted to regain control of his hotel pack, his foot slipped off the elevator door was closed, and that fireman did return to the lobby of the building. The other firemen on the fire floor who had exited the elevator were not aware that this fireman had left the fire floor. In the dense smoke, they could not tell who was present or who was not present. At that point, the officer and one private from Engine Company 7 left the elevator lobby and turned in a westerly direction. At the same time, the officer and the private on Snorkel 13 proceeded down the eastern end of the hallway.
As the companies proceeded to the opposite ends of the hallway, Battalion Commander 1 arrived on the scene. The time was 0211 hours. Upon arrival, he contacted the officer from Engine 7 by radio and asked him what he had on the fire floor.
Battalion 1 to Engine 7, what have you got up there?
I got a lot of smoke up on the 9th floor, origin unknowns, and all the other companies.
Check Battalion 1, I have Adams command.
Exchange of command on the fire scene occurred at that time.
From there, Lieutenant on the Engine Company 7 and the private continued in their westward movement to the end of the hallway.
You stay here. I gotta go back.
The officer discovered there was no fire at this end of the building. He also discovered that he did not have his other firefighter with the hotel packs with him. At that point, it appears that the officer left the firefighter private on the outside of the stairwell door, turned and started to go back to the elevator section to find his other private or to locate the source of the fire. As the officer and the private on Snorkel 13 traveled towards the eastern end of the building, which would be Sector D, Delta, they had gone approximately 15 to 20 feet when they encountered some intense heat from the actual room of origin, which is room 912 of the fire building. At that point, they turned and retreated back towards the elevator section. The 2 individuals continued in a westerly direction until they reached the apartment door of the first apartment west of the elevator. As they approached apartment 905, a very highly distressed civilian exited the apartment door and grabbed the firefighter. It was apparent that he could hear his air mask. There was a pretty good struggle. And as they entered the apartment, they could see a light in the window on the back bedroom side of the apartment. The private being out of there, still fighting with the resident, took his hand and broke the window of this apartment building out. This gesture was done in an attempt to get fresh air in for himself and for the resident. And when the fresh air came in, the resident was somewhat revived and somewhat in control of his own actions.
As the struggle subsided, the resident advised the firefighters that he had a female acquaintance in the room with him, but could not locate her. The officer left the window to search the apartment, but was driven back by intense heat and smoke coming through the doorway. Meanwhile, the officer of Engine 7 continued to travel down the hallway in an easterly direction towards the origin of the fire. As he got within 10 to 15 feet of the room, the fire flashed over. This flashover occurred at 0200-1430 hours.
As it flashed over, the windows on the exterior walls melted, broke out. Flames extended from 15 to 20 to 30 feet outside the window area there. At the same time, they exited the open doorway of the room of fire origin and down the hallway, entrapping the lieutenant on engine compass. He sustained second-degree burns to his hands and to his neck because he was not wearing his leather firefighter gloves, nor was he wearing his Nomex hood. The officer was disoriented due to the injuries and his inhalation of the carbon monoxide, and did travel back to the westerly end, or sector B, end of the building, and was succumbed. The fire was so intense, it actually seared the exhalation valve on the SCBA facepiece in the closed position, meaning that the officer could breathe in, but he could not exhale through his facepiece. The officer pulled the head straps over and was having to remove the facepiece to breathe. At the same time, he went to an emergency bypass function on his MSA, SCBA, by closing the mainline valve and opening the bypass valve to control his flow of air. We do know this occurred because that was the position the air mask was in when we found the officer. The private in the stairwell became concerned when the officer did not return. The private stairwell called 7C to 7A 4 times in 41 seconds.
7C, 7A!
7C being the designation of the private, 7A being the radio designation of the officer.
7C, 7A!
Getting no response, the private donned his SCBA facepiece again and re-entered the
7C, 7A!
west end stairwell door. He moved approximately 10 feet in an effort to locate and assist his officer, which we are convinced he heard in his discomfort from the flashover. As he moved approximately 9 to 10 feet, the fireman was entangled into some cable television wire. The fireman became entangled into the cable television wire, and he apparently did struggle because the cable television wire was wrapped between his legs, over his shoulder, under his SCBA, over the top of his SCBA, which would indicate that he had struggled to get free. The fireman was found with full protective equipment on, with the exception of gloves and a Nomex hood, approximately 10 feet inside the stairwell door.
The fire fatalities resulting from this incident were Vera J. Murray, age 30, expired from smoke inhalation. This victim was found in apartment 905, lying in the center of the living room floor. Joyce Johnson, age 19, expired from smoke inhalation. This victim was found in apartment 901 in a crouched position. Firefighter Lieutenant Michael L. Mathis expired from smoke inhalation, found in apartment 901. And Firefighter Private William E. Bridges expired from smoke inhalation, found lying tangled in cable wiring in the corridor of the 9th floor, 10 to 15 feet from the west stairwell door.
All the companies arrived on scene between 2:09, 2:10 after Engine Company 7 and Snorkel 13 did. So these personnel upstairs did not know what the people downstairs were doing, nor did the people downstairs know what was happening to the firemen on the 9th floor. Of the 5 companies responded, Engine Company 7 and Snorkel 13 were on the fire floor. Engine Company 1 had arrived at Sector D, or the east end, hooked into a standpipe connection, laid 2 lines into it, with the officer and the 2 privates on Engine Company 1 entering the building, going up the west end stairwell to the 9th floor. While they were traveling to the 9th floor, the building ventilated. The chief officer of Battalion Commander 1 called for a second alarm upon seeing all the people attempting to come out the windows and seeing the fire ventilate and going into the 10th and 11th floor windows.
The battalion commander advised Snorkel Company 2, located on the west side of the building, to relocate their snorkel to the southeast side of Sector A and put water into the 9th floor window. The commander additionally called for Snorkel Company 13 to relocate their snorkel to the south side for rescue purposes. Battalion 1 then set up his command post at the southeast corner of the building. At this time, Division 1 arrived on the scene.
Division Chief 1 and Battalion Commander 1 both concurred that the thing they wanted done was for water to be turned into Snorkel 2. That would have created an offensive as well as a defensive fire tactic. The personnel of Engine Company 7 were unaccounted for. The battalion commander was preoccupied with the rescue problems, did not know Engine Company 7 was having a problem. The water was turned into the 9th floor window, and that instant is actually what caused personnel from Fire Company 1 to have to retreat the hallway. As they were retreating, they stumbled over objects that they had not stumbled over going in. One of those objects was one of the firefighters who was down. The fire and the smoke was becoming very intense on both sides of the building now. As the water was applied into the 9th floor window of apartment 912, it pushed it across the hallway into apartment 909, burned through a hollow core door, totally involved that room, and vented itself out the north side of the window. This created a tremendous rescue problem. Other residents had come to the window. There was one woman with 3 children on the 11th floor that firefighters actually thought she would throw the babies out the window. Division Chief 1, after the water was turned in, advised Battalion Commander 1 that he was relieved of Balance Command that Division Chief 1 would now be in charge of the fire situation, and sent Battalion Commander 1 to the north side, or Sector C side of the building, to take charge of operations on that side.
As Battalion Commander 1 proceeded to the north side of the building, he called for a second alarm. At 02:16:52 hours, Truck Company 4 and Truck Company 5 were dispatched to the scene with other second alarm companies. Upon arrival, they received orders to report to the north side of the building and attempt aerial ladder rescue operations. Both truck companies encountered serious rescue problems on the north side. Truck Company 4 rescued a male resident with a broken leg from apartment 903 that was attempting to climb out of the window. They also rescued the 2 firefighters from Snorkel 13 and the resident from apartment 905 who could be seen waving to them from the broken window. Truck Company 5 covered the northeast corner of the building where residents were hanging out of the windows on 2 sides. The first rescue made by Truck 5 was a woman in room 911 who came within inches of losing her life.
Well, I ordered my crew to extend the aerial up to the 9th floor and rescue a woman which was sticking her head out the window at first. And just within a matter, before we could get the aerial to her, she was hanging outside the window by both hands. And in the process of getting the aerial up to her, she was holding on by one hand. And we thought we might lose her. So we
the driver and I worked together to work the aerial over to her, and she reached out with her foot and grabbed the aerial hanging by one arm, and it seemed like eternity.
What happened when she let go?
She let go. She hit the ladder. I mean, it was right there where she could reach it with her foot. It was a miracle.
A second person was rescued from room 1007 on the opposite side of the fire.
The man on the 10th floor, he was hanging out the window too, and when we repositioned the aerial to get to him, he jumped on the ladder before we could even get anybody up there to him and started running down the ladder face forward, you know, to get away, and we were hollering at him to turn around and climb down to keep from falling off the aerial. Well, the next thing, we were ordered to go to the east side of the building. We had people hanging out the windows on the 11th floor on the east side of the building. So we repositioned the aerial.
How much smoke or fire do we see in these areas here?
As high as it would go.
Pay attention to that for later.
Rescued one woman and 3 children. Well, I assigned my crew to go up that ladder and rescue those people. And each man backed the other man up and down that ladder. And at one time, one of the men had to go inside the building and help somebody out that window, which the arrow was too short from the seal. It was stretched beyond its limits. It's a 100-foot perch, and it should only reach 10 stories. And it went to the 11th floor of the building. Once we got the arrow all the way extended, it was about 14 inches short of where it needed to be. But, you know, we just had to do what we could do with that.
I believe the director was on the scene as the rescue operation for Truck 5 was taking place. He did have or take total charge of the fire. He is our fire chief. He takes charge of any multiple alarm fires.
When I arrived on the scene, I noticed a very serious fire. A number of victims hanging from the windows, and observed fire out of the Sector C side of the building. So immediately went to command post, and when I arrived at the command post, I discussed the situation with the command officer in charge. I was not very pleased at that point with what I was seeing as far as adequate strategy, tactics, and surely what appeared to be a lack of a very effective plan, especially in light of the fact that we had all these victims. I had to get very aggressive. I had to get everybody to just shut up, listen to what's going on here, and then I laid out the strategy. It's apparent that we had to attack this fire from the interior side. It was apparent that we had to form rescue teams to get the people out of the building. It was apparent that we had to take access to the stairwells and use them. And so immediately I took the operations chief, who I felt was in the wrong position, and assigned him to the 8th floor, low below the fire.
So when we look at this video and we think about the complacency that we saw in the video a little bit earlier, how do we feel about some of the decisions that were made? Where did the breakdown start with this? Right. And this was a combination, and then I like at the end how this director talks about how everyone was doing everything wrong, and then I did this, and I did that, and I did this. This breakdown started when?
Did it start before the call came in? Absolutely.
I mean, were his members, were his chiefs, were his prepared for what was going to happen with this incident? Was anyone on the same page with anything that was going on here? When those guys got off the rig, Brian, who taught with me the last 2 days, said that when the investigation first came out about this, the truth of the matter is the guy who let his foot slip, he didn't let his foot slip. The reason why he took that elevator back down was he didn't even have an air pack with him. So that's why he took that elevator back down to the main floor. It's also said that the officer never went up with the first companies. When they first got up there, one of the officers was actually downstairs, sitting in the rig. So there was multiple breakdowns. But have we seen these happen at calls that we've gone on, where we've been there 300 times and we kind of take it a little low-key? Another issue was when those first 2 companies were up there working. All the other companies that responded, they were staged, ready to return. And we know what that is, right? They were kind of a couple blocks away, waiting to just turn around and go back home since it was 2 o'clock in the morning. These are all led into the incident. It took the other companies another 25 minutes before they responded and started working with those first 2 companies that were on the scene. What we talked about, someone brought up about them getting off on that floor. Okay, we made a mistake. We're getting ready to get off on the wrong floor. You had 2 officers in that elevator in this scenario. What could someone have done? And you could have probably stopped a lot of this from happening. When those elevator doors open and you see heavy smoke. Right. The reality of it is, what's the first thing people are going to do? They're going to fall to the floor and go forward. If you would have had one officer go, hey, everyone back in the elevator now. Get everyone back in the elevator. Go down 1 floor. Clean your drawers. Get the pucker factor to calm down a little bit and come up with a plan. Get the equipment you need. They didn't even realize that they were missing a guy who had the hose till they made it to the staircase. Think about the 2 civilians we lost. Why did we lose those 2 civilians? What was the common factor in those 2 civilians we lost?
The apartments that firefighters entered.
And what did those firefighters not do when they entered those apartments? They didn't shut the door. And if they,
in the other apartments on that fire floor survived.
If they just would have shut the door, it would have bought them some time. And when he went to look for that girl who was laying in the front room, everyone else survived in that apartment. Why? Because they were over by the window, and she was in a room that was getting beat down. If they just would have shut the door. I look at that incident and I say, those are 2 people that we shouldn't have lost. Those are 2 people that should still be alive today, because other people caused those incidents to happen. We caused it.
Let me jump something.
Yeah, go ahead.
How about when right before they got off the elevator? Did they know which way they were going? No. They know which way that apartment was? Do they have an idea? I don't know. It shouldn't say, because 1 went right, the other 3 went left. They kind of went which way. How would they? Should they have known that before they went up? Where's 905 at? Where's 907? Which way? You said you had fire showing where? He told them which end, right? North or south end? What end is that? In my reference, is that where 905 is? Is that where that fire is going? Do I want to crawl that way towards the fire? I want to retreat the other way, at least to get my bearings and my thinking. Even if you didn't get back in the elevator, which Ray said might have been the best thing to do, they're out in the lobby, they're out in the hallway. Game ready. How many have worn the old SCBAs with the elephant trunks?
Yep.
Right? Mine was always hooked up. I don't understand the whole taking off, putting on, but
carrying my spider hand like that.
I mean, and putting that on with a glove, the old FR gloves used to get, they were like, great for fire pits. Good luck hooking the hose up. So there was a lot of little things that one little thing goes to the next little thing to the next to the next. Kind of what he was talking about the first day, the NASA guy. Look what happened here. And they probably went that way there all the time, because what do they have? Being on the stove, food on the stove, pull station, smoke detectors tampered with. That was their normal for this building.
Think about the candidate that they lost. He's in a stairwell with his officer. His officer says, I got to go back and look for the guy. And this kid's sitting there calling on the radio for his officer. What they say, 7 times in 41 seconds? Gutsy move for the kid to go back in and look for his officer when he probably didn't have any of the experience to do it, and we ended up losing him. He thought, my officer's probably in trouble and I need to go help him. He easily could have stayed in that corridor and sat there and waited for someone else to come and get him or gone back downstairs. He went and tried to help out his officer who was in trouble. Gutsy move for a kid that probably didn't have a lot of experience. And from his incident, someone brought up in one of the other classes, why didn't he have the proper tools to cut himself out of it? That's the call why we all carry the cutters now. That's it. That's the one we all learned the lesson from. And now what does everyone carry in their pockets now? The snips or the cutters, some type of thing to get out of that type of incident. But he would think how sad it is. He's 10 feet from a door of safety and laid there and died because he ran out of air. So this is a real good incident, and we got to give them credit. This is all a reenactment they did after that building was reconstructed, and they took video from the night of the fire. They went and did the reenactment to learn from the mistakes, and so we can all take the lessons away from it. So kudos to them acknowledging a lot of the bad things that happened with that incident. But this was a systematic failure that just built off of 25, 26 calls that have happened and without having a real system in place to deal with the incident. Anything anyone want to talk about with this one? All right, guys, go ahead, take 10, and we'll come back and we'll do a little more. Concerns about wind-driven fires is when we first all started hearing about it, when did we think that they only happened with?
Highrise.
Right. We thought they only happened with high-rise buildings. And after doing research and after them really looking into and all the studies that they finally did with the incidents that have happened, we've realized that with the wind-driven fires, bless you, can happen with buildings as low as 3 stories.
What do we really need to have a wind-driven fire?
Wind.
Wind, and what else?
Open window.
A building taller than the other buildings around it. So if all the other buildings around are 2-story and you have a 4-story building, could you have a wind-driven fire event in that 4-story building? I mean, is it feasible? It is. It is very feasible. And that's the one guy. Everyone hears wind-driven thinks, oh, just high-rise, we don't have anything above this stories. Forget about it. Not the case.
And the big thing you got to remember with the wind-driven fire is, why does it happen? What's going on? Well, what does fire want to do? When we have a basic residential structure fire, and we have fire in a bedroom, why does that fire want to vent out that window? Why does it want to roll out that door? What's the reason for that?
Needs air.
It wants to.
Needs air.
Hero said.
The reasons are what that pressure inside that room that is on fire, that's your high pressure area. Where are your areas of low pressure? When it pops that window and it rolls out the window and it rolls out the doorway. Fire is always going to look for the point of lowest pressure. The heat, the smoke, the fire, it wants to go to the point of lowest pressure. That's how it's going to flow. What happens with the wind-driven fire are a couple things. One, the room starts on fire. Once the room starts on fire, that window is somehow ventilated. Whether we do it, whether the resident does it, whether the fire itself makes that window pop. The third reason is that person leaving that apartment leaves that door open. When you have those incidents happen and you have the wind coming in the correct direction, that's what causes the wind-driven fire. That's what causes the heat, fire, and smoke to travel down those hallways, is those exact incidents take place in that form, and that causes the area of high pressure pushing to the area of low pressure, which is the hallway that we're going to be coming down.
When you see that picture, that window, you don't see flame come out. Is that a good or a bad sign? Bad, right? Because what's happening in all reality? It's blown in, right? So if you actually pull up and you look at the building, you see flame coming out or lapping up, that's actually a little plus for us. It really is. I want to see that. I see this. That's okay. On that window, how about the opposite one?
If you pull up on this structure and you just see this side of the building without the ladders on it, that should be a red flag in your head that something's going on with the wind-driven fire, because is that a norm? If we were to pull up at a residential structure fire and see a second-floor bedroom burning with the window pop, would it be normal for us to see fire not blowing out that window? No, probably not. Our normal thing is that fire wants to blow out that window like that other window's doing. When you see that happening, that is a notification to you that bells in your head need to start going off, that there's some type of wind-driven fire happening in this incident. New York had an incident where they had 2 firefighters go up to the 3rd floor of an apartment, and they had smoke showing from the outside. They went up to the 3rd floor. They made this turn down the hallway. They went to the door. As of the first truck on the scene, waiting for the engine to get their ducks in a row, what were they doing? Probably going up there with a hand can, probably locating the fire, maybe keep the fire in check, give the engine a notification, hey, this is where the fire is, this is what's burning, maybe start their search. As they went in there, they opened the door, they got down, they started to crawl, that window popped. Burned them up right away. Killed 2 firemen instantly. About 10 years later, same building, they had the exact same incident happen, and that's when they went, whoa, time out. We got to figure out what's going on with this wind-driven fire and why these incidents are happening. For this fire here, what is in this hallway to burn? Nothing. There's absolutely nothing to burn. They had 2 2.5-inch lines throwing 250 gallons a minute for over 25 minutes on this fire in this hallway. Why didn't that put it out? Right. All you're doing, all this is a chimney. Until you make that turn into that hallway, are we getting any positive reaction to what's going on there? All we're doing is throwing water on the tip of the fire, like he said, the tip of the blowtorch. We're not putting it out. And that was one of the things that was realized. So what are the things that we're kind of being trained on and talked about doing now? What do we do from the outside now, if possible, when we can't make the hallway? Right. We take the teeth out of it. We give it a punch from the outside. Either with ways we can do it from the ground with hand lines. If it's a little bit higher, what can we use? Our tower ladders. We can give it a punch. And then what are the new fancy dangly things that they've come out with where you're on the 35th, 36th floor. They got the nozzles that come out from the floor below that go into the window of the floor above it. Throw some water on it, and then we can put out the fire.
Fire curtains also something else they tested here in the city in New York. They tested the use of a fire curtain. Go to floor above, drop a fire curtain out to stop the wind blowing in that window, at least to stop off some of that wind fire. That's a tough thing to do. We did some testing with that over on 35th Street with UL, and they worked on some floor below pipes. Just a pipe, iron pipe that comes out with a gooseneck on it, so you could actually put it out the window and hit just the ceiling from the floor below. They found out that drastically reduced ceiling temperatures in that fire floor itself. From what you may have temperatures in excess of 1,200 degrees down to about 200, like that. So it does work, but who has those pipes? Not a lot of people. Who has that curtain? If I got to go up above the fire to put a curtain on one, I don't know. Why won't we just go to the fire and put it out? So there's been a lot of ideas, but just some common sense things we can do to help protect ourselves as well.
One of the guys that I worked with out of the house that I was at, he was on one of the truck companies from one of the fires they had downtown. And he told the story of they got up on the elevator like they were supposed to. They went up to the fire floor. They had heat and smoke. They were the FIT team. They went looking for the fire to let the engine company know where it was. As they started making the hallway, as they went down the hallway, like I said, they had heat, they had smoke, and they saw like a glow in the hallway further down the hallway. And as they got closer, what they realized had happened was the peephole for the door had blown out, and fire was shooting out of the peephole of the door, burning the door across the hallway from it. Would that tell you definitely have some type of wind-driven fire there? I mean, that's definitely some signs of we need to regroup. What would have happened if they wouldn't have paid attention to those signs and would have opened that door? You'd have burned up 2 companies. You weren't going to get in front of that. You weren't going to. I don't care how much water you had sitting in that hallway right there. You would. If you'd have opened that door, you'd have fried 2 companies. So that's something to realize. That's something to pay attention. Look at, if you get that hair standing up on the back of your neck for something like that, you'll understand those sights and sounds of what's going on and pay attention to what's happening in front of you. We'll get back to smoke spread a little bit, and we'll talk about how that smoke spreads throughout these high-rise buildings. We have the pipe chases and the poke-throughs. What do we mean by poke-throughs?
Construction stuff.
Right, I come in there and I'm going to lay the cable line, I drill a hole in something, and instead of spending the $45 on the fancy caulk that's supposed to be used for it, I punch the hole through it, I don't get caught, and I run it through. Now we got a hole in that, easy spread for the fire and smoke to go through. Voids. Think of even just our residential structures. How many of your homes in CIcero, and we'll just go residential, have construction that happened that probably built in a void space that wasn't approved by someone along the way? You can probably go up and down the blocks and just list house after house that has that happen to it. We talked about the elevator shafts, the HVAC systems. For these buildings you're going to go to, most buildings have that guy who's been there for 35 years, who's been one of the engineers who's been there forever. What shift is he usually on? He's on mornings, day shift, right?
The one you're not at, right?
When do most of our bad juju incidents happen with this? 2 o'clock in the morning, right? Who's on the 2 o'clock in the morning shift? The guy who's got 2 years on, who doesn't know where anything is or barely knows the keys for the structure itself. So that if we don't get in there during the day and we don't talk to the guru who knows everything about that building, when we do have to go there for an incident, we're probably going to get lost.
One vertical thing that's out there, what's another vertical thing to spread fire?
Laundry chutes and garbage chutes.
Garbage chutes, excellent one. Garbage chutes is one. Laundry chutes if they have, but for sure, trash chutes, that's one. Sometimes I know the ones we've had, they'll actually put the crap in the garbage chute and it packs up. Packs up like you're packing sausage, you know what I mean? Fills up, you get a fire there, you go. How about stairways? Doorways that are left open in stairways. Stairways are other forms of vertical spread for smoke and fire. Do you recognize which ways to attack and evac for your stairways when you go to high-rise fires? You probably should, because if we want to direct people one way, we should direct them to one specific way in our fire attack building. to keep those stairways as tenable as much as you can, because that is another way for vertical fire spread as well as smoke spread.
For the buildings we're going to respond to with high-rises, we get what's known as the stack effect. And depending on the temperature on the inside of the building and the temperature outside the building, it can change which way the flow path is going to go for the air coming into the building and the air going out of the building. There's a neutral plane in the building, and if you look at the drawing on the wall behind Richie there's a drawing that kind of shows, depending on the building, depending on the temperatures, that neutral plane can change. It can go really low, it can go really high, and that can change the direction on how that air is going to flow in or out of that building. The thing to remember, though, if you're going to be in any type of high-rise incident and you're going to decide maybe it's a good idea to do some ventilation for this building, before you go to the fire floor and decide to do some ventilation, it's probably a good idea to go a floor or two below, pop a window on that side, and get an idea of whether that air is blowing in or out, and you're going to get the cause and effect that you want to happen for that building.
This isn't something that happens in your lower rise building as much as it does in your higher rise buildings. It's more common, you know, so I'm not saying you won't see it, but you might not due to this height of buildings that you have in your neighborhood.
When we talk about using user-friendly hose lays, it's got to be something that you're used to playing with. It's got to be something that you're used to leading out and used to putting into play, because you're going to be in a tight little confined space in the stairwells. It's a real good idea to overtake that floor right below it, and that's where you can lead out that line, and you can put in a nice laid out position so it's not getting all kinked up as you're trying to advance the line through the building. It's important because of the amount of manpower that you have for showing up on the apparatus. You're probably going to have to marry up 2 to 4 companies just to get that line in place. And you're going to have to put officers and firemen in a lot of unglamorous positions. What do we mean by that? Right. You know, someone's going to have to sit at every kink point or every grab point, and someone's going to have to sit there and feed the line. Or the guy who's going to sit there at the sitting there watching how the water is turned on for that floor below the fire. We're going to have to put people in unglamorous positions, but we know what happens as you're advancing the line. What does it take? One person to step on that line, and what happens to that line? It doesn't move anymore. No matter, you could have 10 guys pulling it, 1 foot on that line, it doesn't move, or it grabs one corner and it doesn't move. And the biggest part is the training and the understanding of how to advance that line and how to get it moving forward.
How about lower numbers as far as manpower, running with 3, running with 4? Yeah, we can say this all day, we work where we work, but how do you have those extra guys for those kink points? What does someone have to do? Wear out a pair of boots, right? Move back and forth. Your job may be to shuffle up a set of stairs around a corner, down a hallway 10, 15 feet, fix a kink, come back and get more. That's just how it is. And not saying what's right or wrong, just you guys do more with less, and you guys do a great job with it. You have to make up for what maybe other departments don't have with numbers, or what every department in America is doing. You just have to work a little harder, more diligent. You guys do a great job at it.
And the other part that's hard with it is, because of the size of the companies that are showing up, your officers are not taking that just officer position. They have to be working beats. And it's difficult while those other companies are coming up, because you don't have someone who's just running that sector, putting other companies to work to make sure companies don't do what? They don't take off, don't do freelancing, or they don't go off and do their own thing. They're assisting, helping get that line in place and helping the searches with that first truck happen. Some of the things that need to be remembered about the tools that need to go in with you, and everyone needs to have the good flashlights and the PP. We saw that with the fire in Memphis. A big thing that can help, especially with the truck companies that are going up, are the hand cans. Why? Because maybe you can keep something in check while that engine is putting that line in place. Maybe you can keep it from extending or spreading from that areas. The portable radios is a huge thing now, because everyone's got an opportunity not only to be able to explain what's going on with that incident, but can listen to what's going on and what radio traffic is going on. It's difficult with the size of the crews that are going up there for your first couple companies, but we definitely need tarps up there. And why do we want tarps up on the fire floor?
What did we talk about earlier? How much water does it take to put an elevator out of service? A cup of coffee, right? So if you're flowing any type of water, if you have a sprinkler head off or anything like that on that fire floor, what would that tarp be good for? It uses a dam in front of the hoistway door. Now, we do it all the time, and guess what? They still leak. I mean, it doesn't matter, but it helps prevent it. It can't help. It's better than doing nothing. and it comes in very handy. You just make a big U around the door. You usually get both doors at the same time, but it's something you can do to slow that water from getting there, because once we lose that elevator, it's done.
One of the guys brought up yesterday in the class was saying, you know, they don't have the real good fancy canvas tarps like we used to have. They've got the blue throwaway ones now, right? So he brought up, you know, another option to that is the pigs for the hazmat. If you bring a handful of those up there, they're a little bit lighter, and you can do the exact same thing with those pigs that you could with the tarp, which I thought was a really good idea. Using the thermal imaging camera, when used correctly and when used to help search for what's going on and what's happening, it's definitely a very useful tool.
Would you use it outside a building, the tick? Can you? Can you scan a building and find what floor or what window may be hot? If the sun's shining on it, no. I mean, nothing changes how a tick works, but if you're on a cold side of a building or it's at night and I scan a building and I got a window that's showing white on my tick view, that's kind of indicating me an area, does it not? It isn't normal. Now, you'll get a temperature range, but I get something that's off the chart, kind of give you an indicator.
Bring in search ropes up there to help and notify where searches have happened, where that fire location is. It's a very useful tool that can be used to help the other companies that are coming up know what's happened and where you've searched before that you go down and without having to sit there and explain everything that's going on.
He's got spare bottles up there. How do you bring those spare bottles up? You have webbing, you have a little piece of rope, you have a smaller webbing, or you hold them in your hands. You got so much to bring. Anything you can use to help make your transition up those stairs or your travels easier, lighter, more compatible, that's what you want to do. Put a piece of webbing around the neck, simple girth hitch, piece of rope, whatever you got, so now you can throw two over your tank and be hands-free still.
When we look at office spaces for high-rise type buildings, what kind of issues come into having the open floor plans? How does it make our job harder? Search is a huge area. And what happens with that fire? Is it compartmentalized? No. No, it's a wide open space. And what's everything made out of in all the office buildings? I'm kidding. Everything's made out of the petroleums, which is giving off what? It's giving off its own fuel. It's giving off, once it lights on fire, its own heat. And by the burning process, it's giving off its own oxygen. It has everything it needs to keep burning and burn everything around it that's near it. When we talk about a limited window of opportunity with these large office space areas, what are we talking about? What happened with the fire downtown for Chestnut Street? That was a big open floor, or Cook County building. That was a big open floor plan, right? How long did it take that fire to get out of control? Within 15 minutes, they had the majority of that floor burning, and they weren't getting in front of it. They had windows popped. They had a wind-driven fire. It wasn't happening. They had lost at that point.
How high are most of your cubicles in office space? Not very high, right? Open ceiling, though, right? Wide open room, unlimited spread for travel, for fire, for smoke, for heat. How about for searching in those type of places without some type of reference in your own? In a residential building, can you get landmarks of reference from outside? Exterior walls, where those at, windows? Can you get that in a high-rise building? Maybe a little bit, but how about an office building where everything's cubicle? When you get lost in an interior building, you get on an interior wall, you kind of know it. You can figure out which way walls are running, if this is an interior load-bearing wall or not, which way doors are swinging. You lose some of that in an office space when it's a big area, cubicle, cubicle, cubicle. It's like a maze, it's like a puzzle. So you lose some things you normally do in a residential home that you can't do there.
It's real important that when we pull up on the scene or as we get more information that we're giving correct size-ups and we're giving correct updates, making sure everyone knows what's going on. That was one of the things that was lost in the Memphis fire. There wasn't enough explanation about what was going on and what was happening in that area. Find those building reps. Even if it is the guy with only the 2 years on, make sure you find that building rep and you tie him to someone's side who's in that lobby to make sure anything that you do need, he's going to be able to get you that information for. Locating the fire, that may be a difficult part too. We may have to send multiple fit companies up to check different areas and different floors.
You know what he means by fit? Something we use in our job, fire investigation team. First company, a team up to investigate, that's all.
It's real important we're upgrading these alarms early. We're getting the manpower in. We were saying it could take an hour to get all the people that we need into that area, so it's real important we start those companies in early. options that we have, if we do have some type of wind-driven fire, we do have the possibility of going to an apartment next door to you, going into one of the bedrooms in that apartment, putting a hole in the wall, which may take some time because what could the walls be made out of? Right. So it may take some time, but if we put a small enough hole where we can just put the nozzle through there, we can do that same thing of putting that punch on that fire without being able to do it from the outside. Other things that it does for us is, if we do that, and we lose that room, we close the door, even if it's a hollow core door, we bought ourselves a little bit of time so we can get out of that apartment. We then leave that apartment, go back into the hallway. We can now close the solid door. We bought ourselves some time, we regroup. We've lost 2 apartments, but have we injured or hurt anyone at this time? No, we're still winning. We're still winning because no one's hurt. One of the guys in one of the classes in the last 2 days brought up about, what if you put the hole in the door, or I'm sorry, the hole in the wall, and you have a couch or something on the other side. If you're doing it in that way, do we really believe that there's anything left in that apartment that's going to stand in our way? If you've got a wind-driven fire in that apartment that's been burning for 10, 15 minutes, the reality of it is everything's probably burned up in that apartment.
Think about too, how many apartments you've been into. You walk in the front door, what's usually right here to the right, or depending on the layout, right or left. Usually is a closet, right? Next way, either is a hallway going straight back to the door, a kitchen, or another room. Just kind of how the layouts are. So if you can know from a neighboring unit, from a floor below, if you got to put a hole in, get the layout of the land. You get that rough idea.
When a lot of the high-rise stuff first started coming out, they used to tell us to take the apartment across the hallway from it. How come they've changed that? If we do have a wind-driven fire and we open that door and it chases us into the one across the hall from it, where's that fire probably going to go also?
Oh, you were saying, I didn't know you were, my bad. I thought you were saying take it before you try to attack the fire, giving the fire a place to go. You're saying it's an exit for us.
Yeah, absolutely, absolutely, yes. Yeah, and we can give it somewhere to go if necessary, but we don't want that to be our point of hide. So where do we want it to be? An apartment next door. In New York, that happened where they had a fire. They got the door open. They had a wind-driven fire. It chased them down the hallway. 2 of the members made it into the apartment. The 3rd one didn't. While they were in the apartment, they realized there was still a guy in the hallway burning up. One of the firemen opened the door, went into the inferno, grabbed the guy, pulled him in the apartment. He ended up living. The guy who pulled him in won New York's highest award for pulling him, and they both got burned up. We need to have a safe place to go to. It needs to be one of the apartments next door. That needs to be done before we open that door. Whether it's a small fire or a big fire, we need to have somewhere to go.
Something Jeff brought up earlier, when you check that wind direction earlier, right? If you can check it from a floor below, which way it's coming. If the fire is blowing this way, and this is my fire department, I know I'm going to have that wind-driven event. Maybe I do want to open this apartment to give it a place to shut out so it doesn't come down the hallway with me. Maybe I open up this apartment, and the wind comes this way, it's helping me push it out. It's going to lap up. So got to think of those, not saying all of them aren't a viable option, but which is the right one at that time. Maybe I open that unit across for a place of refuge. Maybe not, because it could blow in there, or the one I might want it to blow out of there to help me with the fire. And I take that neighboring unit. And if I take the neighboring units, how hard is it to breach some of those neighboring unit walls? How hard it would be to breach that wall right there? You know, that one up there, we definitely do. Yes, sir.
Just 1 minute. Engineers, grab on your rigs, grab your cell phones, and go out downstairs and go swap them out.
When we show up at this, and we're talking about the standpipe systems, for the highest point in the building, for the newer codes and everything, what is the lowest pressure that is supposed to be at the highest point in the building? Depending on when the building was built and when the codes are, it could be 100 PSI or it could be 65 PSI. So a lot of these buildings for the lower floors, they have pressure regulating devices on them. How can that be harmful for the things that we're doing? That's exactly it. And
or you get an automatic one, and the stream looks pretty, but what do we really have? Low pressure, low volume.
So those are things when you need to think about. You need to know for your buildings that are in your still districts, which ones have the pressure regulating devices and how you can go around them. the other thing which we're going to get into in a little bit is we also recommend getting the flow gauges on there. And why that is so important is because sometimes you can think you have enough water coming out of the system, but you really don't for the amount of hose and the type of nozzle that you have on for your attack devices.
Debris systems? Debris systems, is that a problem? Do you, how long, if you're the guy in the standpipe, how long do you flush your standpipe for? Is there a set time? How long do you flush a hydrant? So it looks good, right? Until I have a clear water, until it looks like stuffing up. We've had to flush standpipes, which I'm sure you guys had, syringes, washers, conduit pieces, wire, you name it, cigarette butts, drugs, whatever in the world are in the standpipe system. So with those nozzles, they're going to have a smooth bore, which you guys do, which is awesome. What happens to those? They clog up right away. We had a fire out south, and hats off to the company guys. The officer was Corky Ortega, and he was really big in the high-rise, and he drilled his guys all the time. Especially when he got there, they didn't want to drill. They didn't like drilling. He came there and he changed the whole attitude of this house. Well, they had a fire on the south side that they were losing, and no one could get this one standpipe to work. Corky went up there with his crew, got a pipe wrench, got the cap off. With the pipe wrench, got the valve to turn, flushed it. When they flushed it, the water that came out was like coffee beans initially, then coffee grounds, and then kept doing. They actually got that standpipe to work, and that line that they used was instrumental in helping put out a lot of fire. A fire they were losing. So debris in a standpipe is huge. Nothing changes. You're the hydrant guy, or you're the engineer going to hydrant, you have a guy going to the hydrant. You flush that, you flush these wind until you're sure it's clear. Now, could I still get something that comes loose? Without a doubt. And when you guys using smooth boards, it's a huge plus.
There's a real possibility with some of the fires that we go in for any of the high-rise that we're going to need a backup line. We need to make sure for our backup lines we're getting at least the size hose that we've been dealing with, or hopefully a little bit bigger. So it would be, for you guys, it'd be the 2.5. And that's just so if we do start losing, we have enough water to try to hopefully gain control of it again as we're going through it.
Well, what happened here in CIcero? If you're getting up there, you get your 1 3/4 up for smooth bore, it's not up. What is the second line that would come up to help support you guys? Would it be another 1 3/4 or would it be 2.5? Would they go up to larger? You guys, is that something you do, or is it call on the situation and who's the commander?
Call.
Okay, so it's not a standard procedure we have. Okay, that's what I was curious about. How about the, he had up there the master stream device. How do we use a master stream device in the hallway? And can we? You guys have any blitz nozzles?
Yes.
Can we put that in the hallway? What can we feed that with? Do we have to use 4 inch or can we feed it with 2.5? Can we put that in the hallway, put a pry bar across the doorway, let the back pressure go back to the little blitz nozzle itself, either with webbing, chain, whatever? You can put that in the hallway. Then if we got to move it forward, can you actually move that forward some? Kyle, you're going to move it forward, Kyle, but you might want help. But can we move that device forward too? The new blitz fire nozzles and the lines? Yes, we can. Options and just capability.
When we're talking about stretching the line in the hallways, the way that I was taught when we were first doing it was we would go up that next staircase above us. What are some of the negatives of doing that?
Wind-driven fire.
Wind-driven fire, right.
What's another one?
Right, and even when you open that door, the chimney effect is going to happen. And one of the things that they've realized is some things that happen when you put it up on that next landing is the couplings or the hose itself can get caught in the banister or could get caught on the stairs. So you got to send someone up that chimney now. The recommendations that they're saying now is don't put it up that next staircase. Use that floor below or use the stairs going down the rest of that staircase. A big thing to remember though is if you are going to do this, make sure with this nozzle, before you charge the hose, make sure the nozzle is back in this direction. Because as you charge that hose, what's that hose going to do? It's going to push forward and it'll push into the door and prevent you from being able to open the door. One of the things that was talked about with one of the city fires was that they used the smoke tower for the attack stairwell. And in a perfect world, that would be the choice that you would use for evacuation of the people. But when that was decided at the fire, when he used the smoke tower, it was looked at with the amount of hose that he was going to need if he was going to use that other staircase. And with that other staircase, he was looking at, I think, at another 150 feet worth of hose. So for him, the best option was to try to use the smoke tower to put it out. Most times, if there's 6 floors or less, we should be only using the stairs. 7 or above, we can start using the elevator to the 4th or 5th floor. If we do have a heavy fire, we should definitely think about not using the elevators if those elevators do go to that floor. And we need to be careful about overloading the elevators. Most elevators, how many people are we going to get into them? Yeah, maybe 5, and then with all our gear, we could be overloading some of the elevators in our still districts. So we should probably find that out before we start putting people in.
What do you put in? What equipment do you put in? Does the whole engine crew go in?
Well, Paul's case, he would have to go first, and then the rest of his engine would take a run.
What's he trying to say, Paul? What's he trying to say?
Yeah, I'm muscular.
That you're muscular?
Yeah,
right?
exactly.
Right, we all can't have
Right.
an appetite, right?
I know.
It's all right. We like a pint or two.
I
But with that
I
being
lift
said,
weights, I don't do CrossFit.
but with that being said, who's going in? A truck guy with an engine guy, the engine officer, the guy with the hose. Who else? Do you want the truck officer, or maybe a guy with a set of irons, some force entry tools? How do you marry them up to be successful if your elevator gets stuck? All truck guys aren't good, or all engine personnel aren't good, or just doing those functions. You need that mix, and we can't overload. Because you ever been on the elevator that's stuck and there's 6 of you or 7 of you in there? Who can even work a tool? Is it even possible?
What are some of the issues that we run into with scissor staircases?
Every other floor.
Right. And if we don't pay attention to what floors we're getting out on, we could give false information. So it's real important we pay attention to that and we notify the other companies that are coming in. Especially with a high-rise fire, when you have auto aid or mutual aid coming in, they may not know your still district. They may not understand the staircase problems. So that's something that just needs to be announced on the radio and talked about.
Everyone understands scissor stairways? Anyone not understand scissor stairways? You'll have one set of stairs come down, this door gets off at the 6th floor, this one, it only gets off the 5th floor. So they're rotating, they're opposite of each other when exits are. So a company go up, not paying attention for that. Yeah, I'm in the 6th floor, but you're really not. And there may be only one way out. And it gets you out on a different end of the building or a different area.
The picture on the left here is the picture of the inline pressure gauge. The big thing to remember about the inline pressure gauge, Brian yesterday and the day before was telling the story when Evanston first got him. They don't leave a guy stay there once that water is turned on. He turns on the water, gets the pressure to where it needs to be, and then he goes and assists the company because they just don't have enough manpower to leave someone there. We need to understand the difference between static and residual pressures though, right? Because what was happening in Evanston was they would get it up, they would turn it up to 90, he would see that it's at 90 on the gauge, boom, he'd be gone. He'd go and help the company. They'd start working that line down the hallway. When they open the line, what did the line do? Then that guy doesn't know what he's doing, he's an idiot, so now that they have to flow for a while, make sure they have a good flow of water, make sure that pressure stays at that 90. The other recommendation is when you're using it, the pressure gauge with the hose cabinets, is to put an elbow in there. And the reason why is the studies that they've done, they said that first kink, because how does that 2.5 usually come out of the cabinet? It's either straight down or straight out to the side. Well, that hose, that 2.5 or 3/4, it wants to bend right away. So if we put the elbow on, they said that if you take that first kink out, that first kink can cause 45% loss in pressure. So by just adding the elbow, you take that first kink out of it.
Inline pressure gauge, you don't have them. If you're flowing water, how does that guy in his standpipe know that? Right, hopefully radio communications. How about if we have a lack of radio communications? We already talked about how the radios suck and high rises, right? You ever put your foot on it? You could feel water go through it. Put your foot on it against the edge of the stairs, the very front edge of the stairs. Does it push easy? Or is it like on prom night for some guys, their first night out, it's as stiff as can be? You feel real hard like that, but you don't feel the water going through. You don't hear that rush of air. You don't feel that water, I don't know, kind of makes a waterfall sound or kind of the gushing sound. Put your foot on it. Is it hard? Yes. Is water flowing? These give you an indicator when you start having your radio problems and other things like that.
Make sure in your bags or in your pockets you have chocks or door wedges. An 18-inch pipe wrench. Why do we want an 18-inch pipe wrench? It fits in the bag perfectly and it'll fit around the wheel so if we need to turn it. Make sure you have spanners and a wire brush. We may need to clean some of the fittings. Hose strap or webbing is going to be real important to make sure that hose stays in place, or it might make it easier to pull that hose to where it needs to be. This is just a picture of actually using the elbow and the inline pressure gauge. For your systems that you're going to run into, a normal Class 1 system is just a 2.5 connection for us. A Class 2 system is usually the 1.5 connection for the residents, and it usually has a piece of hose there. And a Class 3 system is going to be both the system for the residents and the 2.5 connection for us. Depending on how your SOPs are set up for your towns and for your communities, you got to decide who's going to hook up to what connections. A lot of the newer buildings have what? Combination systems. So it doesn't matter if it's sprinkler or standpipe connections. Know what your rules are for your departments and the towns that you're going to be responding to. Make sure you know if you're hooking up, if it doesn't have a combination system, if you're hooking up to a standpipe or a sprinkler system first. This is your normal sprinkler connection. Some of the newer buildings are getting the Storts connections for the combination systems or the sprinkler or the standpipe systems. What are some of the negatives of having a large diameter Storts connection for these fittings? Pressure. What could some of the pressures get up to for what we have to feed the buildings? Over 200, right? What is our hose tested at with our large diameter hose? 200. We are now using supply hose as fire attack hose. Problem number 2. If you have an incident with the hose where it gets a hole or glass falls and cuts it, you've just lost water to the building. If you have 2 2.5s, if you lose one, you at least still have the other one feeding the building. Evanston has these on a lot of their buildings. They hook up a Y to it and have 2 2.5s go into it just so they don't have those issues. If you do look at, they do make large diameter hose that's high pressure that you can use for this, but I guess it's like 3 times the price of regular large diameter hose. So.
Yeah, but with the 2 2.5s, if you lose one of the 2.5s, it's just going to come out that.
Well, not if it's clappered. A lot of them are clappered.
Yeah.
The ones that have the 2 in the system are clappered. You put a clapper Siamese up in there, yeah, the old style. Yeah. Yeah, the old ones we saw before, those are clapper. That's why it doesn't matter if you lose a 2.5. With this, yes, but when you put the Y on there, you can always either shut one manually if you lose one, if it's just a regular gated Y, or if you have the older ones that have the clappers in it, then you're okay.
It's recommended while you're going up and you're hooking to the standpipe system and you're doing recon on the fire, it's a good idea to have a minimum of 6 people trying to get everything done and everything put in place. That's very difficult with the limited manpower that we have, but that is what is recommended for it. For the fire attack, the fit team officer needs to decide what stairwell is going to be used. A lot of times the fit team officer is going to be that truck officer. Why? Because while the engine officer is getting his hose and everything together, the truck officer can decide what is the best approach for this fire. He can try and find out where the fire is, what's going to be the easiest staircase to use for it.
Who we got here? We have Forest Park. How many have a designated engine and truck on their departments? CIcero does? Yeah. Forest Park, you do? Anyone else here? Berwyn, who else? Stick to anyone? For you guys that don't, we may say engine and truck, don't take it out of context. Performing those duties or responsibilities. We may say that, but it's just our Southside slang.
A lot of times when jobs are being completed at high-rise fires, one of the things that's not being communicated is whether the job was completed or why it was not completed because something else was started or you got tied up. If you were sent to do a search of the 5th floor of a high-rise building and 3 apartments in, you get a victim out, it has to be notified not only that you have the victim, but the search wasn't completed and where it was stopped. In a perfect world, you get a chief on the scene right away and he can assume command and start putting people in place on where it needs to be, and then the coordination can start with the rest of the companies that are showing up. Someone really has to take control of that lobby, though, for multiple reasons. One, you don't want companies coming in doing their own thing and fighting with each other on how things are going to be done. You want those companies coming in and assist the first 2 companies that are up there. Another problem is with the residents. If you have a long fire that is going on or you have an incident that's going on for hours, not only are you going to have people who live in that building coming in and out, but once they see it on TV, every one of their relatives is going to be showing up at the building and popping into the lobby to see what's happening. Make sure as your companies are pulling up on the scene, as you have the multiple companies showing up, they may have to park at some distance away. It's real important that they know what equipment they need to bring to the lobby area. Bare minimum, they should be bringing extra bottles for the companies that are already up there working. Get a good idea of what's happening with that HVAC system from the person that is the representative of the building. If they don't have a good understanding of how that HVAC system works and can't explain to you if it's helping you or hurting you, it's a real good idea to shut it down and let it not cause more problems. Make sure it's definitely not hurting you. If for some reason you do have the radios that are not working inside the building for whatever reason and you don't have the phones on the walls or in the elevators, you may have to set up runners to go from floor to floor to hand the information, which is going to tie up more of your personnel. Make sure anything that you notice that's going on in the building, whether it's rescues, whether it's people that are being held in place, whether it's you see conditions changing on the inside. Command in the lobby or people in the stairwells may not know what's happening. It's real important that information is handed off and that command and the fit officer and everyone else knows what's going on in the rest of that structure. The tarps we talked about a little bit earlier, it's real important. Maybe for the first couple companies that are on the scene, we may not be using the elevators, but if you have an incident that's going on for multiple hours, you may be using the elevators to bring equipment up and down and make it easier for the manpower that are trying to do this.
Should you talk about freight elevator at all? We're using a freight?
Go ahead.
Some buildings may have a freight elevator, right? Freight elevator is an option. Problem sometimes with the freight elevator, we can't have control of them like we would with phase 1 and 2. Plus side of freight elevators, though, they're much larger, can support more weight and equipment. So it's just something to consider at a fire scenario. Is that area remote from where the fire is? Can we maybe use that to get up to some of the floors or get some people up there? It's something to consider.
It's real important we put someone of responsibility down in the fire control room to make sure that things are working the way that they're supposed to be working. And if they stop working, that we're assigning, that we're letting command know what's going on so we have a plan of action when those things are happening. We should also have people on the exterior of the building giving updates on what they're seeing from the outside on all ends of the building, from everything from how the fire has changed to people hanging out of windows. We need to set up safe areas on the inside of the building. Most residents, if you have, when we look at that fire in Memphis, and we saw them bringing the couple people down that aerial ladder, what angle was that aerial ladder at?
They had to be backed up to the building, right? I mean, they literally had to be kissing the building.
And what type of fire conditions did we see coming out of those windows? Absolutely nothing. How much personnel did we tie up trying to do those rescues when if we would have maybe sent one person to that floor, one firefighter, even two, relocate everyone to one apartment, and what do most people just want to hear?
It'll be okay.
Everything's going to be okay. That's the perfect example. And if you put one or two people up there, you took people whose conditions were at 9 or 10 and ready to jump, down to what? A 5 or 6, because now they have a fireman sitting with them. So that's a real important thing to remember with that. That was another lax in what was happened there. They started doing the rescues. Just to do the rescues for that ladder. That fireman climbing up 100 feet with all his gear on, climbing back down with that one person. Climbing a ladder straight up in the air like that, I mean, that's exhausting work. Now you're bringing someone down again with you?
Unless they're a kid, get walking. They'll find their way down. You got other people to get it.
So you got to think about that. And realistically, should those people with the fire conditions that were in those floors, should anyone have been coming down those ladders? Absolutely not. Absolutely not.
They'll crawl down. They want to get out.
It's real important we check 2 or 3 floors above the fire when we're doing searches and we're trying to find out what's going on with that fire. What do? Fire area, fire floor above the fire, 2 floors above, maybe, and then we start from the top down. What do we do about stairwells now? What's the big thing that we learned with stairwells? We got to check them. We got to start from the top. We got to work all the way down, make sure those stairwells are clear. So that, again, that takes more companies and getting people up to those top floors and start their way down.
We got dinged pretty good on that one high-rise fire because people came in the stairwell, couldn't get out, then we couldn't get back in, came down, and they were moving up and down stairwells. Well, firefighters checked those stairwells and those floors, but they checked 18, now they moved to 20, did they miss them? So that's why it was a big thing, and we had some problems with that with the Cook County building.
When we talk about companies going up to the fire floor, it's real important that they go up and they don't have empty hands. One of the other lessons that was learned at that fire was, especially with Chicago, what does every Chicago truck guy have in his hand?
Which tools? They're born and bred out of the womb. They're carrying two tools.
Closet hook.
What's that? They don't even know what that is. Are you kidding me? We don't even know what that is.
Really? We love them here for some reason.
A pipe pole and a pick-headed axe. A pipe pole and a pick-headed axe. We go to a water incident. What does the fireman off the truck with? A pipe pole, I get. Maybe you know someone. The pick-headed axe, I'm not really sure. Maybe just ballast. Well, that's the con. What's the building construction of these buildings? Do we need so many pipe poles? Do we need so many pick-headed axes? No, we probably need your irons, your rabbit tools, your Halligan bars, your sledgehammers, your mauls, whatever. Use the appropriate tools.
And I mean, imagine climbing up 35 floors with a 6 or 8, 10-foot pike pole going up the stairs that way. They said, I think at the Cook County building, they had a room where they had 35 pike poles sitting in it. Because every truck guy that came up through the staircase had a pike pole in his hand. So we need 1 or 2 up there for maybe ceiling tiles, maybe checking areas, but we don't need 35 of them up there.
And you don't like closet hooks, ever know?
Who does?
Ever know?
Belong in a museum. So there's certain fees.
For any of the high-rise type of incidents or anything where you have multiple floors, it's real important to have those RIT teams set up 1 floor below the incident that's going on, and it's recommended that you have 6 people. So you may have to marry a couple companies together to get 6 people up there. You may need the extra personnel to try to get the RIT to be able to do their job correctly. A couple things real fast is, can we use a tower ladder as an outside standpipe system for some of the buildings?
Yes, we can. Yes and no.
What are the negatives?
Oh, yes, we gotta know.
Right. Once you do that, the tower ladder is kind of useless for anything else. It's a stationary standpipe system. You can't use it for anything else.
Straight sticks. I mean, your trucks have pre-pipe waterways? Yes. If not even it's a straight stick, can we run a line up the main? Sure. Well, we can.
With the staircases, and we bring a hose up the well. What does that mean when we bring it up the well?
Sure, up the interior of the staircase, not on the stairs. Saves you some length, saves up trip hazard, all that stuff.
But you should tie them off on every floor to take it away.
Right,
you will have to do a tie off, right? Because the back pressure is going to pull on the weight.
Kyle hold it. Look how big it is.
Those forearms won't get tired. You won't leave early.
That doesn't
no.
CrossFit. He doesn't get tired.
CrossFit can't. Listen, I have to deal with him in the rest of the building. He stays there.
Well, you can burp you over it later, thruster it later.
Yeah, sure.
No, we're not going to go there. Leave the pants on.
One of the other options is you could go to a certain floor and drop hose out the window. One of the incidents that happened in Chicago was they dropped the hose out the window and it landed on the awning on the front of the building on the first floor, because if they would have gone one more apartment over from the floor below, it would have missed the awning. So from the 7 floors above, he's trying to swing it out over the awning. How well do you think that worked?
Or the other thing is they throw it out the window. They just thought one length's enough. Well, it's about 12 feet too short, and there's guys like this and poles like, just add that other length. Get it down. It's got to hit the ground. It's got to hit the ground. But going out a window is a home run. Which window and from where? Neighboring unit in the fire floor or from the floor below? Ideally, the floor below. Ideally, you want to be the floor below. Could it be the floor below, though, near the end of the hallway? How about where the placement of where your fire department is? Who were we talking about when we were meeting with you guys, with the chiefs? One of the buildings, they said they have the standpipe connection right in the center of the building, center of the hallway. I don't know what town that was. And it's a pretty long, Forest Park. So what's the hallway lead out length?
It's the common. It's longer than that.
It's longer than what your standard standpipe or your high-rise lead out will be. Let's say it's 150 feet. So to go from the floor below, and if it's 150 feet from the center of the hallway to the stairway, what are my options then? Can I run 2.5 to the end of the hallway, put a gated Y, and then run up my standard lead out, get it up to the floor above, whatever. There's always options, so don't just think that you're limited to that.
one of the things that we like to talk about with this is, anyone ever hear of Andy Fredericks?
Tackle for fair.
He
was.
Different Andy Fredericks. Different. Same but different.
He probably said some stuff too.
He was a New York fireman. He taught with the Institute for a long period of time, and he was killed on 9/11. And he was known as one of the engine gurus. And he has numerous things on fire engineering that if you're ever in the mood for some reading on some engine tactics stuff, it's real good reading. Go back into their archives and look at some of the stuff that he wrote. And one of the things that he used to always say was, approach it like gentlemen. And what he meant by that was, when we show up and when we turn the corner, a big joke that he used to say all the time was, when a garbage man turns the corner and he sees a load full of garbage there, he doesn't go, oh my God, there's garbage there. He's not surprised. And when we pull up and we're sent to a structure fire, we probably shouldn't be surprised too. We should approach it calmly. And when he says approach it like gentlemen, one of his other sayings he used to always talk about was, he would say, you Chicago guys, you'll get up there before us New York guys. He says, but we'll get up there and we won't have the issues, we won't have the problems that you guys have as you're leading out those lines. We're going to have every door chalked, we're going to have the correct amount of line, everything's going to be in place, and we're going to hit it like gentlemen. And it's something to think about, especially with the high-rise fire stuff. Make sure that we have everything in place, make sure everything is the way it's supposed to be, make sure it's practiced, make sure you know it, make sure you learn it. Any questions or comments? Thank you for being attentive. It's been great the last 3 days being here with you guys. You guys have a lot of pride in this area and in CIcero, and it shows. Thank you for your attentiveness to what we did.
Thanks, guys. Appreciate it. I got nothing to add. I was just